Welcome to this tutorial on mobile cloud computing. First, I'm going to talk about what mobile cloud computing is. Then I'll provide some application ideas, then some problems to overcome when implementing a mobile cloud computing system, some strategies for dealing with these problems, and then a specific solution called MAUI, and then the results of MAUI. So the idea behind mobile cloud computing is to use remote machines to increase the capabilities of a mobile device. And we need this because mobile devices are very resource poor. Primarily, they are restricted by power. The battery will run out very quickly when running intensive tasks. And so to increase battery life of these mobile devices, we can run these intensive tasks remotely. And we'll see some application ideas on the next page. So some applications for mobile cloud computing would be games, running more complex games with increased processing power and memory, and also computer vision tasks like face recognition, navigation, text reading, and then also natural language processing is another idea for how we could use mobile cloud computing to increase the capabilities of a mobile device. So next we're going to talk about some of the problems to overcome when implementing a mobile cloud computing system. So the first problem is, how are we going to offload the code? There are three main architectures for doing this, which we'll discuss in detail on the next page, but they are the client-server model, a virtual machine, and a mobile agent model. And for each of these, we also need to decide which parts of the application will be run remotely and which will be run locally. Another problem is, when do we offload this code? When will it benefit the smartphone to run remotely versus locally? The next big problem is, how do we handle mobility? So if the user runs out of range of a cell tower and loses connection, how do we handle this? And lastly, how do we deal with privacy and security? If we're transferring information across the network to these remote machines, there's a chance that they will be intercepted, and so what are we going to do to handle this? And in the next page of the tutorial, I'm going to talk about some strategies for dealing with the how to offload code problem. The three primary methods of implementing mobile cloud computing are client-server, virtual machine, and mobile agent. Virtual machines are currently the most popular because it requires the least amount of modification of an application, and so less work for the developer. And with client-server, we need pre-installed software for each application that wants to run remotely. And so this requires a lot of work on part of the developer to write this software that needs to exist on the server. And similarly, Mobile Agent uses mobile code and surrogate machines that are nearby to process, and so it requires a lot of work on part of the developer to get this to work. And so I chose a system called MAUI, which is in the virtual machine category, and we'll look at that in the next section of the tutorial. So the focus of the MAUI system was to increase the battery life of smartphones by offloading processes when it believes there will be a benefit to power consumption. So if there isn't going to be a savings in battery life, then it will not run methods remotely. And they also aim to have this work with very little effort on part of the developer. the system will automatically choose when to offload code. All the developer has to do is mark methods as remotable if they want that particular method to have a possibility of being remotely executed. This currently only works with managed code such as Java and .NET. And primarily, the two main components of this system are the profiler and the solver. The profiler gathers information about the device, such as the power consumption and how much power will be consumed by a certain number of CPU cycles. And so with this knowledge, we can determine how much energy a method will use based on how many CPU cycles it requires. And it does this by looking at the history of methods. So if we call a method and it requires a certain number of CPU cycles, then the next time this method wants to run, we can estimate how much power it's going to use. And it also looks at the current latency of the network. And they do this by sending a 10 kilobyte packet to the Maui server, and they look at how long this transfer takes. And so the solver uses this information to determine which methods should be run locally or remotely. And the big problem here is that methods might not be worth executing remotely by themselves, but as a group, the smartphone could benefit by this. And that's the example here. So if we implement any one of these methods just remotely by themselves, we will spend far more battery power sending the state that we need to run that method remotely. However, if we remotely execute all of these methods together, we only need to transfer the state of this find match method. And then since it's already running remotely, we won't need to transfer the state for the initialize face recognizer method or the detect and extract faces method. And so we will only be spending this about 1,000 millijoules to send the state for find match, and then we save all of this power here. And so how it does this is it looks at, it creates a graph like this figure here, and it maximizes this equation. And basically this first equation, what it is it's going to be the energy savings. And this constraint here just ensures that we are always under a specific latency. So if the latency of remotely executing a method is going to be greater than 5% of the latency of running it locally, then Maui will not remotely execute it. And so this here just ensures that we're not going to remotely execute any methods that will be greater than this latency value L. And this here constraint is I sub v is the mark that the developer puts on each method saying if they want it to be run remotely or locally. And so this is saying we're not going to remotely execute any method that has not been marked as remotable. And the results of this, we can see that the face recognition, so they tested the Maui system on 3 applications: a face recognition app, a video game, and a chess game application. So on the face recognition app, we can see that the Maui system uses a lot less power. In the video game, there is some savings in power in certain scenarios. In the scenario where it's using 3G, we actually spend more power trying to remote methods. And similarly in the chess game, we save battery power when we have a Wi-Fi connection, but not when we have a 3G connection. They also look at processing speed. Once again, in the face recognition app, we have much greater processing speed, as well as the video game. The chess game, the processing speed is lower in certain scenarios when using Wi-Fi, but also takes longer in other scenarios. And they also look at Maui's ability to run intensive programs which would not have been able to run at all on a smartphone without the system. And so they run a speech recognition application, and they chart the CPU usage for the 2 cores in the Maui server, as well as the memory usage. And they say that the memory usage on the Maui server is greater than what would be available on the smartphone by itself, and so this app would not have been able to run without Maui. And that concludes this tutorial.